Hello, guys. Good afternoon. Thank you for joining me here. I'm Priyanka Naik, and I'm from Palo Alto Networks. I don't know why that failed. And I'll be talking about effective data platforming with open source tools. Most of them are from CNCF open source projects for faster insights. Just a little bit about me to recap. I've been an engineer for about 17 years. First started off as full stack, then moved into backend and went into data engineering just because it was a new unexplored space for the problems that it held. And here we are. So to start off, I want to step back and touch upon the journey of data engineering so far. Before data democratization, there were the stakeholders generally for data engineering teams used to be senior leaders, marketing teams, or sales teams, and mostly asking for reports, right? And then the tools mostly used to be batch processing tools, and you deal with large amounts of data in data warehouses. I know why this is glitchy. Okay, stabilized now. Okay, so and then moving on to the automation, it was fairly minimal. You just needed scheduled jobs to run and fetch data, bring the data to data warehouses where you would run your, typically EMR jobs or Spark jobs, batch processing jobs. But after data democratization, we see a change in the landscape where you have stakeholders not only from the non-technical background, but also from the technical background. Now you have software engineers, AI, ML engineers, data scientists, and tools which need to be, which need to provide for faster access to data and enable transactional databases and as well data warehouses, because you still have the old stakeholders. And fairly, automation has to move along with it to be on par with software engineering, and because of the demands really of the kinds of problems we are solving with the data these days. Moving on. So you need the need for this efficient and robust data platform architectures becomes evident, and so where a shift from original approaches is sort of needed, and to consider existing third-party services can be fairly expensive to start off with. So, and also based on usage and cost, data engineering teams need to weigh between third-party versus open source, and also you have to think about delivering value early and continuously. So, sound architecture with clear aims becomes key, and to solve that, let's look at some of the data platform architectural aims. So here, a combined, cross-pollinated set of architectural concepts between software and data engineering, these are things which we are fairly familiar with. For instance, modularity, you want to handle data, you want to have separated data for different purposes, and then separation of concerns, where you want to separate ingestion from processing and separated from storage as well. And having a loose coupling of the system, or the entire architecture within the architecture becomes necessary. This helps, whenever there's a change in some part, it need not break the pipeline of your data ingestion or processing for that matter. Scalability at every part of the pipeline also becomes crucial, and low bar for entry and to maintain as well. Like you want to have like people come in and be able to maintain the data platform as soon as possible. That's just a nice to have feature. And obviously low cost. So far, so good. It depends, all of this is great, but what about stakeholder requirements? This is something we often get asked about as data engineers. People ask us, when are we going to get to see the data? When are we going to get to handle the data and use it, right? So if we look at the general laundry list of like what stakeholders want, they want to have the ability to handle and join and enrich data from varied sources. There's documents, existing data, which are present already in warehouses, and maybe from tools you want to begin collecting data, and you want to have the ability to bring them together and show things, right? So the transmission of varied data sources to points of usage, they want just the data to be available for reporting purposes or probably even third-party tools. And obviously, like, a quick ingestion, processing, and availability of lots of data sources is also very crucial for such stakeholders, because many times they might be hands-off. So you might want to look at like how to give deliver the benefits of a data platform sooner rather than later. And similarly, in ML and AI engineers, they want data as soon as possible and the most relevant data which is available at that time. So what are the stages of development for such a architecture, which considers both data platform, like trying to satisfy all the architectural aims and also the stakeholder requirements? And how will we build it? So this, there are several stages, obviously, which I want to elaborate on here. First is obviously understanding your data and pre-processing. The second step is thinking about what tools you want to use based upon the kind of requirements you want to satisfy, and also identifying the platform build tools that you want to use, because they can fairly make it easy or make it harder for you to maintain the platform. And putting it all together, you have ingestion, streaming and stream processing, storage and dissemination, and obviously you want to monitor your data platform architecture and also think about the security features that you want to provide. Other features like data catalog may be very useful for people who are hands-off. They're not technical users. For such people, you would want to think about how you want to build the data. So yeah, coming back. You want to serve even your non-technical users in a better way. And a data catalog is sometimes gives you visibility as to what data you're collecting and serving them. So the how, the first step which I mentioned was understanding your data and pre-processing. This is about really knowing the data and the data sources for your stakeholders before making the system understand it, right? So all of this will involve having conversations with your stakeholders and understanding what sort of data they want to bring in, and how do they want to access it and everything. So thinking about whether they are structured, semi-structured, whether they're stream data, or if it's something where you have to convert a batch to stream, and how frequently does the data change, and what is the size by which the data grows regularly. And you want to also talk to them at this point about the purge policy, how relevant is a two-year-old worth of data, how relevant is it, just in the last week, right? So you want to have those kind of conversations. And one of the most important things which we neglect at this point is mapping your more ubiquitous synonymous fields in master data. Each team uses different terms and really just different terms to identify the same thing. So you want to ask questions like, is this product ID, which you call within your team, the same as the team ID, which this other team calls it as? So you want to be able to relate your fields, and you want to have a way of relating those fields in a way that you can later on know that, okay, this means the same thing, so whenever you're joining or enriching, you can use similar parameters. And obviously, cleaning your data, pruning unused data fields is one example of it. The other thing is also standardizing data and event representation. CNCF's cloud events is a nice example. There could be other ways in which you would want to standardize it. Proprietary, ways of, establishing your format of events and data. And the needs of stakeholders, as I mentioned, like, do they want reports or insights, and are they more hands-on or hands-off or both? So you want to have these conversations before. Now, based on this, we want to gather our tools. Schemas in data are very important in the beginning. Sometimes, surprisingly, they are an afterthought. After the data comes through, everybody is like, okay, how does the data look like? What are the fields? What is the, what are the fields that we are interested in, and what we need to focus on? So this is what I would call a stitch in time, really like saves 9 later on down the road. So first, you want to pick the kind of schema management that you want to do. You want to have a schema registry, which is really great, like to maintain your schemas, the versioning of your schemas and evolving them. And typically, you have like Confluent Schema Registry is a very well-known tool. It is Confluent community licensed, and there are certain restrictions on it, which you might have to, like, think about, like, if you want to have a forethought, you might not want to use it, but it's something nice to start off with because it has all the bells and whistles. And in place of that, you can always use Red Hat's artifact registry. There is a nice blog from Red Hat where you can, where they just say, like, you just drop this in, in place of schema registry. But yeah, I haven't tried it. I would suggest, if anybody wants to try it, that'll be a great option. And also using Confluent Avro Converter, this does a really good job of integrating with the schema registry, and detects the schema automatically as soon as the data comes through, let's say Kafka, and it sort of stores it and versions it, evolves it as new fields and old fields change. And some of the other tools, obviously, which I will be mostly focusing on here are open source and cloud native, Kubernetes, obviously, on the cloud of your choice, and Kafka, which I will use as like a ingestion pipeline platform. And this is something which many people might not know. There is a project called Apache Camel. There are several connectors that Apache Camel has, and which they have built specifically for Kafka Connect, which are very useful. You'll have to tweak around a little bit, play around a little, and do a little bit of modification here and there to get it to work. But most of the time, many of the general use cases are there, and that's one set. And there are also some free connectors which are available within Confluent's hub. And for stream processing, you can start off with KSQLDB in your dev environments just to quickly start off on looking at your Kafka streams. But I would suggest in production, obviously, Flink is a better choice. And I think even the folks from Kafka and Confluent are moving towards Flink, supporting Flink. And Strimzy, it's a CNCF project as well, where all Kafka and Kafka Connect and relative ecosystem tools it can run within Strimzy, and you can use Kafka more, in a more managed way than if you don't want to use, say, MSK or something. I would suggest try Strimzy. And cloud events, as I mentioned, for standardizing your data. So, and then a few more things, why we want to choose Kafka is because of its capability in handling large data feeds and inbuilt scalability, and just having that ecosystem around it is also really helpful. And Kafka Connect, ability to integrate with several data sources. I think that's one of the most important aspects of Kafka Connect, which I really like. And you can also build your own connectors within Kafka Connect, so that's really great to have. Observability, obviously, you want to see there are data catalog tools which help you observe, look at the schema and the data that is flowing through. And this is really helpful because for you as a person who is expected to deliver on on your promises to stakeholders, you want to be able to use data catalog. There are several solutions. I will not name them right now. And platform monitoring, we use Grafana, Prometheus, more so with Kubernetes than any other thing, and they're pretty good and robust. And moving on, let's see, the platform build tools, this really using Helm to run Kafka and Kafka Connect, the connectors as well, within the Kafka Connect. There are CRDs for that which Strimzy provides. And Strimzy itself has its own CRD to run on Kubernetes and schema registry as well. So you can just build Helm charts for all of them and deploy them. Terraform is great, which can help you deploy things for your data stream applications, stream processing applications like Flink or even KSQLDB headless apps. Yeah, and again, any deployment tools of choice, Jenkins or Git pipelines, any of them are great. There's really just a way of building your CI/CD around the data platform. That makes it very, sort of like a software platform, and helps you manage it much better, and have your data engineers focus on what insights and what data products they can deliver on, rather than just fixing things here and trying to change the data type there. These are all real world problems which data engineering teams deal with, and it's a pain. So so within the ingestion, right, so this is really how you want to consider, based upon your data sources. You can either push events into Kafka or have Kafka Connect do pull-based streams. As I mentioned, there are several connectors, source connectors for different source types. And SMTs exist, which also help you deal with a specific message, per message transforms that you can perform, flattening, casting data types from one to the other. And as I mentioned, schema registry, different levels of compatibility. So Confluent has all of this, but yeah, you can try to also leverage the artifact registry from Red Hat as a drop-in replacement. So yeah, that. And moving on next to stream processing. Here, one thing which I really found helpful is creating lookup tables. And this is why I want to pitch stream processing in place of batch processing for data engineers is you are dealing with one message at a time, and you're dealing with like a small chunk of messages or data at a time, rather than like dealing with like a TB worth of data and trying to handle them in like your scripts, trying to build windows and aggregate and transform stuff within that is a pain. So I'm one of those evangelists for stream processing compared to batch processing, and it really definitely makes a difference in how you maintain it, and what you get out of it is quite valuable. Storage and dissemination, this is, again, like you have Kafka Connect. So as I mentioned, there is source connectors, and similarly, there are sink connectors for different target locations. And here, too, you can leverage the Camel project or free connectors from Confluent Hub. There are paid connectors, but which are probably available via Confluent's own cloud service. And then for instance, I want to talk about like the BigQuery sync connector, which when it integrates well with Kafka, and then the Kafka Connect connector also integrates with the schema registry, identifies what the schema is for a specific piece of data, is able to evolve your tables on BigQuery on its own. It creates, updates the tables based on the schema, upserts into the tables or new partitions, and the data is now readily available. Any new change that happens at the source is now replicable, like without any intervention by the data engineer. Such abilities are, can add a lot of value, obviously, to our pipelines. And as we all know, data warehouse storage many times is also used for reporting, and for also training models and building models for ML and AI. And also, many times your stakeholders might want to send the data to other systems, in which case you'll probably have to use some cloud-specific tools to say AWS's Lambda or Cloud Functions in GCP, for instance, and then be able to read from the topics or the streams and then write to your preferred destinations. Monitoring and security, this, as I mentioned, Grafana and Prometheus are, once you fairly integrate them into your platform and data streams, they can add a lot of value, alerting when there is an issue so that you are proactive in handling them. So securing everything with RBAC, this is very important because there are times when there are ad hoc users who just want to access certain data, but they don't need it after that. So you want to have like time-based revocation, for instance. So putting it all together, this is fairly like an abstract representation of how it would look. And you have Strimzy, within which you're running Kafka and Kafka Connect. And you have the schema registry, which integrates, and stream processing runs on top of Kafka. And you have all of your data catalog, alerting, automation, monitoring, and RBAC as your important pieces within the architecture. So this builds like a wholesome architecture that once you set this up, this really takes a lot of time off of people's hands in focusing on the kind of problems that they should be focusing on and not dealing with pipeline failures, for instance, for like a data type change. So when we built this, like what would we learn from this, right? Like some of the advantages, as I mentioned earlier, there are Kafka and Kafka Connect have good integrations and ubiquitousness due to the usage of standards and useful tools like the ecosystem built around it. And KSQLDB has a few downsides. This was something which we began realizing early on. It has a way of doing certain things very easily, like enriching and joining data. You can do it fairly easily, but then if you want to aggregate within a window, for instance, then it begins to sort of fail. Whereas Flink adds a lot of value there. And so resolving your schemas automatically, this is very important. This is something which, when I started off, was like I literally wrote schemas by hand and evolved them when people change their schemas at the source, and it's not a fun thing to do. This was, a few years back when things were not as available as they are right now, the kind of tools that are available right now. So optimizing your transformations with stream processing, again, adds value. And so always, this is another thing. This we usually neglect in, while we are building a data platform, is we ignore talking to stakeholders, but we should always talk to them to ensure that they're benefiting from the data that we are generating for them. And if no connector exists, there is a way in which you can, the whole formula of building a connector is also available, that you can build them yourself and also learn from existing ones which are open source. And some of the open source communities which we used were like CNCF's, Strimzy and Cloud Events on Slack, generally engaging with the community, trying to understand what are the general problems that they were solving. And Apache Camel project on GitHub, you have issues. The issues page on GitHub is a fairly active one. You can post issues, you can ask for enhancements, but if you want, you can also fork and build your own enhancements on top of those connectors. I'll want to just end this talk with this quote about how we want to keep on learning, and we'll always be evolving. And thank you so much for your time and attending this talk. And please feel free to ask any questions. Thank you. No questions? Okay.
Hey, I've got a quick question for you.
Yeah.
In terms of data quality and kind of that end of testing all of your transformations and the final product coming out of your platform, do you have suggested OSS libs that you like for that?
So just making sure I heard you right, you're asking about data quality and how to ensure data quality?
Yep.
Yeah, so data quality, you have to sort of study your data sources. Like as I said, the pre-processing step, which I mentioned, really focus on the data quality. It should not be an afterthought. You want to think about it initially. As I said, some of the problems that I have encountered are, there are 5 different terms multiple teams use for the same thing. and then they each has like a set of items under them, and you want to bring them all together. And how you bring them together also matters. So that is one of the problems. The other one is finding there are fields which were used like a decade back and no longer in use, which are not updated. There is no relevancy to those fields, making sure that you weed those out initially itself. And SMTs are a great way of doing that. Like anytime you want to do that, like whenever you're, let's say you're doing a pull-based model, like you're pulling the data, you want to see, okay, these fields are like, that are not needed, but they exist in the data source, and you don't want to rely on you don't want to have a dependency on that other team to fix that stuff. So you can use those, but you'll always have to have this conversation with the stakeholders. Yeah.
So that's at like the first layer of just like from pure ingestion, but you're not necessarily like suggesting paths after that.
Could you come closer, please?
Oh, sorry.
That's okay.
Are you suggesting only at the ingestion layer, or like what about like post transformations or whatnot? Do you have additional layers of data quality checks that you like there?
Yeah. So what happens is initially like you join your data sources, or let's say you enrich them. You end up with bad data. Sometimes there are duplicates. Duplicates is like the low bar, like for like and deduping data. There are several strategies that stream processing like gives, like Flink gives, like several ways of like deduping data. Which you can use. I haven't encountered other kinds of issues there, these kinds of issues, but if you solve them beforehand, you're not going to mostly encounter them there.
Gotcha. Thank you.
Yeah, no problem. Thanks. Right. Thank you all. Looks like there are no more questions, and I'll see you all. Have a nice evening.